Professor at Department of Electrical Engineering in deemed University Agra. We invite him to present us how that smart can have a smarter ecosystem and unlocking efficiency and automation. Please, Dr. Rajeev.
So thank you very much and very good afternoon to all of you. It's my pleasure to be here today and to present the key case studies which I have developed as academicians and comes from my labs. So building a smarter future. So for me, if we talk about the traditional systems, we have a big infrastructures, and many of the customers either they are not connected, we can see here around 8% of the world population is not connected with the grids. They are still living in the dark, and the reliability is the another constraint. We can see in the second picture here, the darker area is representing the reliability of the grid. Grid is available for the few hours for the many customers which are connected with the grid. So the challenge is means why we have the grid connected, but the poor reliability. That is there are two constraints in the power system. One is the energy fulfillment, and the another one is the matching of the demand, power demand in real time. If we have a sufficient amount of energy generating stations which are able to generate the energy which is required for the 24-hour, but if the peak demand is going beyond the generations at particular certain limit, a certain time, that may be the cause of power outage for particular locations, and generally utilities do this type of thing. So here now we are going to fulfill this demand at the generation, and we have distributed generating stations. It may be the wind power plant or the solar systems as the close to the load end, and these are the carbon-free. So now the earlier in the traditional power system, the problem was we have the generating stations and the fluctuating is the load. But now with the integration of the renewable energy, both the things are fluctuating. We have the generation is also intermittent in nature, and load is also. So this is the now big challenge, that how we'll manage the things so that the power demand or power management can be done in the grid level. So to manage the things, either sometimes we have to do the load setting, sometimes we have to do also the generation setting, and that's not the good idea. We have to think about it. Either we need to go for the reinforcement of the system, or we should go for the curtailment of the generation. Because if a business person is coming into the picture to fulfill the demand, he doesn't want to shut it down their plant for a long time, because that's the loss for him. So now we can also see the lot of rooftop solar systems. But if we have connected the rooftop solar system, but the reliability of the grid is not, or the properly monitoring of the generation at the rooftop level, as well as the monitoring of the demand inside the building is not properly matched or twinned with the grid, that may be another cause of the curtailment of the generation. And if this curtailment can be minimized, so we can achieve the power outage levels very early as compared to the, we will go with the traditional systems. So the another load is coming the electrical vehicles. So most of the governments or this private sectors is also promoting to come with the go green and use the electrical vehicles. But if we have not the reliable systems, or the digital technologies is not available for the communications in a smarter way for the generation as well as the load end, so that is the main cause of the power outage. So if we have the electrical vehicles, then that can be used as a source whenever the grid is grid has the not sufficient generation from the renewable or the traditional power plants. because with the renewable, the problem is like intermittent in nature, so the inertia is going to decrease again and again. So that time the electrical vehicle may play an important role. Either it's parked at the home or it's parked in the office. So that time the business model come into the picture so that they can feed in the power to the grid whenever it's required, and they can charge it back whenever like it's low cost, it's available at the low cost in the real time flexibility. So now if we talk about like we can see the like vehicles to vehicles charging. Most of the electrical vehicles producer are providing these functions, either vehicle to vehicle, vehicle to grid, vehicle to load, like this type of smart systems they are. But now still we are waiting for the initiatives from the grid side, so that how can we manage our grid in a smarter way, so that we can use our waste assets in a way to increase the system reliability for most of the customers which are connected with the grid. And this is their expectations from the customer side. This is another thing, like we have discussed about the interconnections, but further can we, like if we have a digital system or the readable guidelines or the standards, if they are the part of the control algorithms, how they can contribute for the energy reliability. Like, so this is the case study I have done during my PhD at IIT Mandi. So here I've considered an autonomous microgrid for the residential area. So like if we have a demand side management system, so how the cost of the overall cost, like I'm talking about the capital cost of the system. So in this we have considered the different types of loads which are listed here. We have the LED, like we have classified the loads into 3 categories based on the residential. One is the cycle based, like refrigerator is there or air conditioners are there. So their settings may be changed as per the requirement. And another one is like we have the multiple lights inside the rooms. So based on the availability of the energy, they can cut it down, or as per the requirement of the customer. Sometimes they keep it on because they are not aware that they will use the power in a smarter way, they can get the more reliable for the long time, and as well as they will get the energy at low cost. Means I'm talking about the per unit cost curtailment here. Now next one is we have the refrigerator and the washing machine and water pump. Generally we people do the washing in the early morning or in the late night whenever they come back. But now we have the smart washing machines. They can be connect with the smarter systems, and the user as per the user comfort, the user may give the input, okay, what we have a time constraint at till 4 o'clock my clothes should be washed, and it will take around 30 to 40 or 1 hour. So whenever the sun is available, that time it will run directly with the solar system. So the storage cost can be reduced in this manner. Here means the capital cost of the battery bank, which is depends on the energy requirement for the 24 hours as well as the peak. Like based on that, the energy 2 ratings is there. One is we called it the ampere hour rating, and second one is the type of battery. Which type of battery, like C1, C2, C3. So the C number is giving the how much maximum power we can either take it out from the battery or feed in to charge the battery storage. That's the constraint is there. So if we make it in a smarter way, we manage the power in a smarter way, how can we? So this is the cost of the number of, now another level of thinking is like, if we go with the DC technology, because most of the loads at the generation is DC, all the sources are DC here. So if we will go with the DC systems, we can see the number of cost of the converters can be further reduced in a drastical way. Like this is a very small pilot project, but here we can see around 16,000 Indian rupees. This is not a small amount for a small house of 1 or 2 kilowatt of for the remotely areas. Here we can see based on the solar systems how the intelligent system or smart control system is managing their appliances, different appliances like different lights, controllable based, and the next one is the like critical based, like washing machines, how they have shifted from the early time to the later on, because they need the cloth washed they want to use it next day, not the same day. So the customer give their comfort, okay, till 4 o'clock or 5 o'clock, I want the clothes to be washed. So it's accordingly the control algorithm is shifting their appliances operations. So the objective, the key outcomes we get, like the small size of the PV and battery, and because of this, the capital cost is reduced. Converter and battery power losses has been reduced because of the DC technology. And the high efficiency, because the number of converters are decreasing, so the losses in the storage as well as the losses inside the battery, because this system is giving the smallest size of the battery pack is sufficient enough to supply the electricity for 24 hours for the critical loads. So in this way, if we are charging or discharging the battery less, it means the efficiency of the battery will come into the picture, and that is around 80 to 85%, means 15% we are able to save the energy losses inside the battery with the smart management. And the high reliability, because here we can see in the second graph, the SOC of the battery is shown for 24 hours. Like it's showing that based on the system is automatically forecasting the state of charge of the battery to supply the next critical load based on the solar system. This is the another like very smart systems here. Till now I've talked about the DC technology, integration of the load and source, etc. But this is one more next level, like the occupancy, based on the occupancy level as well. Like we can see in our house, multiple appliances are continuously remain on throughout, at the different time instant. Still, if the occupant is not there, so we have marked the sensors to automate, which is extracting the information of the user available in particular room or not, and the information is fed it to the control system. So based on that, that is the another input we are getting, and based on the power use or energy use inside the building is significantly decreased. And the management of the different loads based on the electricity prices of the utility, it's again shifting the load from high price to the low price. And in this way, the per unit cost, we can see here the microgrid buy from the public utility or the grid around 19% lower energy, because it has reduced the energy consumption inside the building. And the cost is also 5.4% at low cost, it's by the energy. The next one is the microgrid sales the electricity to the grid at the high price. It's like a share market. So whenever the prices are going high, the grid is feeding to the prosumer is feeding the power to the grid, and whenever the price going down, it's again managing the things. And the local source, it's all managing to keep the electricity reliable inside the house. And the battery and hybrid system is also there, like hybrid car is there, or some other, it may be the plug-in, or maybe the complete electrical. Based on that, we can, here I've considered like one electrical vehicle, so profit is around 11% over there. And the home electricity bill is reduced significantly, around 6%. So if all the components are like the same building holder is the owner of all these components, so we can see how much benefits can be for the user end. So now for the next level, like we have talked about the business model, etc. And generally we are doing, as a power engineers, we are just bothered about it. But we also have like some other requirement of the user, like the water supply, good quality. Generally in most of the cities, we have like the centralized system which is distributing the water in the different houses, or like a gas and others. So this is the smart microgrid systems. This pilot project is funded by the University Grant Commissions, Government of India. For me, like as a startup here, we have developed one smart systems for their academic buildings, and the source is managed like further how we can reduce the automation system. Here we can see the closest, if the 5 or 10 or 15% students are sitting in the class, so it will just just switch on the closest appliances of the occupants, and the remaining will be automatically switched off. And the good thing is here, we are just using the CCTV data to operate all these things. No other sensor is required, just relay is required to one of the appliances. So this is all about another DC systems. This is, we can see, we get a lot of death globally. And if this system is at 48 volt, this is the safest for the low voltage level. And because the appliances rating is not too much high, the power rating of the DC fan is around 20 to 25 watt only, and it's operating at the same RPM. Okay. The good thing is here, another benefits of the DC appliances, we can control it in a better way as compared to the AC technology-based fans or light. Okay, so these are the key. Smart microgrid system provides opportunity in a simple way or flexible for integration of the RES, their intermittency issues may be sorted out, or EV integrations, and a smart system provides the integration of with the national grid. Fast electrifications at remote areas can be done because this system can work in the grid connected as well in the isolated mode. So this is all about from my side. Thank you. These are my 2 books which are published by the Elsewhere and the IET, and we can find out these books in most of the reputed libraries of the world, like MIT and NIT or NUS Singapore, etc.
Yeah. Thank you. Thank you very much, Dr. Rajeev. Big applause. Thank you. Thank you very much. I think it's very interesting for presenting that. It's so fascinating, these use cases, and it's showing the importance of standards. Yeah. So we will be, any questions for Dr. Rajeev? I think it's kind of very clear use cases. We can invite you to stay with us, Dr. Rajeev, in here, as we will continue our...
I think the 2 panel discussions and the presentation by Dr. Rajeev, I think were absolutely brilliant. Lot of information. I have about 4.5 minutes to do the whole summary for all this wonderful content. I have about 5 pages, so this is going to be a speed. Thank you. Okay. First of all, Jim, I think you sounded more like Captain Kirk on the Starship Enterprise, charting new path and encouraging everyone, okay, join me in this journey. But I think you put it very aptly. We can shape the future, but we all have to get on the ship to do it. I think that was a great foundation on which the next panel came on. And let me go through my notes. The next was a panel discussion where we were discussing about many things, including the digital future. There was a conversation around what can be done and what are the key points to take forward. And a lot of points coming up on how to really make standards deliver value. It was about smart, about what smart really means. I can do 16 plus 17, but I'm disappointed that Uni would not think of me as smart. So, but that also tells us that smart means a lot of things. But the key to real smart implementation is taking everybody along. And I think that point came out through all the speakers, and Thomas summed it up very well, making sure that everyone sees value in this. Then Dr. Rajeev, I think you and I need to have longer conversations. I'm the chair of the systems committee for LVDC, and it was music to my ears when you were talking about DC. The good thing is that IEC is already addressing end-to-end DC standardization. We were always having an HVDC committee, TC115. There is the system committee, LVDC, which is now empowered to write standards as a pilot on the low voltage side. MVDC was missing, and this time in New Delhi, It is historic that SMB has also approved the setting up of a medium voltage DC also. So end-to-end DC standardization, and you brought it out very aptly, that the loads are going DC, the generation is going DC. Now how do we connect them effectively across? And so system level standardizations that are required, I think that came out beautifully. The last panel discussion and the presentation before that from Damien, REQIF, I think, remember this, I think from Germany and France there is a strong push for this. It is part of the digital world that we are moving toward. Looking forward to further development and how you can begin to bring it to a global solution and move from a pilot to mainstream. The last conversation was very good, and I think Rajneesh summed it up very well, which was to say, be a standards maker, not a standards taker. I think that puts it simply but straight. At the heart of the conversation was also that the industry is very important, that we need to get the industry engaged. My personal view on this, having been on the other side of this, I think the question we need to ask is, what is it that the CEO wants and what do we need to tell the CEO? We from IEC community, how do we engage with the CEOs so that CEOs think of standardization and as another tool in their so many tools for developing their businesses and their work for the future? So it's not just about innovation and R&D, it's not just about putting more money into it or salesmen or another manufacturing plant, but also thinking of standards as a tool or as an arrow in their quiver, which can be used for furthering the cause of the company or the business. I think that would be really interesting. Last but not the least, I have to thank a lot of you for the wonderful week of the IEC GM. I'm taking the liberty of first thanking the Indian National Committee, which has a lot of members here. I don't remember all the names, but I want to specially thank Rajneesh, the Secretary of the Indian National Committee. Just wave to everyone. I think over the last 2 months, you must have had hardly 2 or 3 hours of sleep per day, because at all times of the day he would, and night, he would wake up, receive messages, reply to messages, and work with national committees all over the world, right from visas to arrangements to this venue. He's been doing everything, and he has a wonderful team. So the whole staff of BIS, they've done an amazing job of putting this thing together. A round of applause for you. The various vendors who have helped with making this IEC GM what it has become. Also the venue authorities in Bharat Mandapam. What a beautiful, modern venue this has been. The halls were fantastic. The facilities were excellent. The India Habitat Center, where there were a lot of meetings, and the India International Center. Rajneesh, please convey to all of them our collective thanks. A round of applause for all of them. I also want to specially thank the chefs who were here. I don't know how they managed the absolutely delicious meals every day and a different menu. So this shows you their skill set. So a round of applause for the chefs who prepared the fantastic meals for us. Last but not the least, thanks to all of you from overseas who came here to take the time and effort to come to India. There are 2 phrases that I want to share. Both are from Sanskrit. The first one Philip also mentioned in his speech, which is Vasudev Kutumbakam, which is the world is one family. We are all actually one family, and nothing like standards to showcase this. That's how international standards are developed, used, proliferated, and they create value in society. The second one is Atithi Dev Bhava. This means really, and you have seen this happening this time, the guest is God. This is an ancient Indian phrase which actually sums up the spirit with which BIS and the whole team has welcomed you. I think a round of applause for the spirit with which they've all worked. Thank you very much. If I forgot to thank anyone, it's my mistake because I also want to run over to the farewell party.
But
So,
before that,
you
Mr. Vimal, well, the world is a one family, and I would like to thank everybody and Mr. Vimal on that.
Thank you. Thank
And,
you.
and as proposed by BIS and our hosting committee, we would like to invite all the speakers and all the